Hello everyone, welcome back to my channel, the WAR Diary. Please subscribe and like my videos. Today, we're going to look into a dramatic shift on the battlefield, how Ukrainian drones have transformed the skies over Moscow into a firestorm. We'll examine the exterior, the interior, the performance, the safety features, the unique selling points, the price, and then finish with a conclusion. Buckle up, this is intense. Let's start with the exterior. Outwardly, what we see is a wave of unmanned aerial vehicles lifting off from launch zones, crossing into Russian airspace, and homing in on targets deep inside Moscow, region and beyond. These drones are not subtle. When they strike, they leave glows of fire, clouds of smoke, ruptured facades of buildings, and disrupted infrastructure. In many news reports, the capital's outer districts have seen explosions, fireballs, windows shattered by blast waves, airports forced to temporarily halt flights, and energy substations knocked out. For example, one recent attack caused significant disruption at Sheremetyevo Airport in Moscow due to drones approaching the city. The exteriors, the outer shape of this campaign, is bold. The drones operate in waves, in swarms, sometimes dozens to hundreds at a time, overwhelming air defenses and creating chaos. The visual of the attack, night sky, streaks of drones, ignition of fuel depots. As one article described, Ukraine's drone swarm hits Moscow, Russia's defenses tested amid diplomatic firestorm. From a production/engineering perspective, the exterior design of these drones matters. They need to be relatively stealthy, long range, possibly low observable, able to evade radar and air defense measures, especially when approaching the heavily defended Moscow region. Some of the Ukrainian-made long-range UAV, one example, the FB-1, are described as having radar-absorbent materials and extended ranges. As the exterior spectacle goes, when these drones hit their targets, the result is visible. Large fires, towering plumes of smoke, disrupted infrastructure, and a heavy psychological impact. Now, moving into the interior. While we rarely get full access to the inside of these drone systems, given their military nature, we can infer and discuss what the interior means in this sense. The internal architecture, electronics, sensors, propulsion, warhead integration, guidance systems, communications, and counter measures. Let's delve in detail. Inside these drones, advanced miniaturized electronics sit at the heart. Navigation systems combine inertial measurement its IMUs, satellite navigation GNSS, and possibly terrain, reference navigation, or optical sensors for final approach. The Ukrainian FB-1 drone is described as having inertial systems augmented by satellite guidance and electronic counter measure ECM capability, meaning it can resist jamming attempts. That means within the housing, you'd find navigation circuits, inertial sensors, GNSS receivers, microcontrollers or embedded processors, algorithms for path planning and target home-in, and perhaps machine vision or other sensors for terminal phase alignment. The airframe likely houses a warhead compartment modular, perhaps selectable between fragmentation or shaped charge warheads for the FB-1 example. Internally, you'll find explosives handling, safety systems, arming mechanisms, and detonation triggers. Again, for the FB-1, the description mentions modular warhead weights of 60 kg to 120 kg, depending on mission. The propulsion system is mounted within. Some of the new Ukrainian systems are jet-powered. For example, the UJ-25 Skyline is reported to be jet-powered, which means internal structure must handle higher speeds, increased thermal loads, fuel tanks, intake, exhaust, and cooling. You'll also find within the drone communication links for remote control or telemetry, possibly data links to transmit back reconnaissance or status, or to receive updates. There will be electronics for autopilot, for flight stability, and for guidance to target. Some may carry sensors or cameras to provide imagery or condition feedback. The interior also houses power systems, batteries, maybe hybrid systems, fuel or propellant tanks, circuits for actuators for control surfaces or thrust vectoring. The interior structural design must balance light, weight with durability, And the electronics must be shielded from EMP or jamming or counter-electronic warfare. We can also infer internal redundancies to survive partial damage, for example, sensor redundancy, backup GNSS switch, inertial fallback, etc. Given the need to evade air defense, interior acoustic and electromagnetic signatures must be minimized: shields, grounding, heat management, radar. Absorbent materials and perhaps anti-radar coatings themselves may line internal surfaces. The interior of the drone is therefore a highly integrated, layered architecture of hardware and software, warhead and missiles, sensors and steering, communications and control. From a user perspective, i.e., from the military that deploys it, the interior matters because reliability and performance come from these inner workings. Maintenance access panels, control interface modules, health, monitoring of subsystems inside, fault detection, and possibly modular replacement parts may be built into the interior. One can imagine the quality assurance inside, testing of navigation circuits, vibration isolation for electronics, securing warhead mounting to avoid misarming, shielding of wiring from EMI, ensuring thermal management so that heat generated by electronics or propulsion does not degrade performance. Interiors might also feature self-destruct or fail, safe systems to prevent sensitive payloads being captured, so wiring and logic for that would also be placed internally. When the drone is launched, the internal systems go from standby to active. Sensors align, GNSS locks in, autopilot kicks in, guidance route is loaded, warhead is armed only near target, and final approach sensors engage. If we think of the sensor fusion inside, there may be radar threat detectors or RWR radar warning receiver that inside detect enemy radar emissions and trigger ECM electronic counter measures or evasive routing. So the interior is absolutely critical. Without high-quality interior architecture, the exterior spectacle would fail. In essence, the interior is the brain, the guts, the unseen backbone of what the public sees when firestorm erupts in Moscow's skies. The performance of these drones is next. Performance here includes range, speed, payload capacity, responsiveness, survivability, stealth, and strike effectiveness. Reports describe some of the Ukrainian drones penetrating deep into Russian territory, reaching targets in the Moscow region and beyond. For example, the Moscow Times reported that at least 44 Ukrainian drones approached Moscow in one attack, and in total dozens were intercepted over multiple regions. Range-wise, some designs like the FB-1 suggest ranges up to 600 km. That allows them to strike well beyond the front lines into the enemy's rear areas. Speed and altitude, while exact figures are often classified, the fact that some are jet-powered like UJ-25 suggests higher speed and reduced time to intercept. The top speed of the baseline aircraft is referenced in the Wikipedia article for UJ-25 for the TOP as variant, but the actual specs are not fully public. Payload, warhead weights of 60-120 kg in the FB-1 example. Maneuverability, if the final approach uses optical or terrain sensors, that allows more precise strikes. Survivability, many of these drones are designed to evade radar or jamming. The swarm tactics force the defender to expend resources multiple times, raising the chance of success for some drones. Swarm tactics increase performance not just of the individual drone, but of the mission as a whole. Strike effectiveness, the visible result of large fires, explosions, airport disruptions, and power substation damage in the Moscow region and nearby areas indicate the performance is operationally significant. For instance, on 4 July 2025, Ukraine launched drones that damaged a power substation in the Sergiev Posad region near Moscow. The performance is therefore not theoretical, it is real and disruptive. The ability to force airport shutdowns, to damage energy infrastructure, to get into highly defended airspace speaks volumes of performance. The combination of range, payload, stealth, and swarm tactics is the key. Next up, safety features. While in a typical commercial product review, this would refer to user safety, here in a military context, safety features relate to reliability, destruct mechanisms to avoid capture, fail, safe modes, electronic integrity, and minimizing collateral damage or unintended consequences. These drones reportedly include electronic counter-measure systems to resist jamming, which enhances mission safety for the operator and the drone's integrity. For example, the internal systems of the FB-1 include ECM capabilities, self-destruct or mission abort systems. Many long-range strike drones are designed to detonate or crash in remote, unpopulated areas if they lose control or navigation, limiting the chance of capturing sensitive technology. Also, for safety of the operator, secure communications and hardened data links reduce the risk of interception or hijacking. The interior architecture with redundant navigation sensors provides safety in the sense of reduced mission failure. Furthermore, by using swarm tactics, individual drone losses are expected, so the system is designed with cost-effectiveness in mind. Losing a few drones does not ruin the mission. That tolerance of loss is part of safety in a military sense. In addition, from a strategic ethical viewpoint, Ukraine claims these drone attacks are aimed at military or infrastructure targets, not purely civilian. While war inevitably causes risk to civilians, the defender's air defense system must counter drones to protect civilians. From Ukraine's perspective, the precision and penetration are meant to minimize unintended damage. And finally, there is the safety of larger infrastructure by striking energy, logistics, or air defenses deep behind enemy lines. Ukraine hopes to reduce risks on its own territory by shifting the front line and forcing Russia to divert resources. In other words, safety features for the operator nation and for the mission success are built in through system design, sensor arrays, redundancy, self-destruct/fail, safe communication security, and mission planning. Now let's talk about unique selling points. What makes these drone systems special, especially in the context of this video review? First, long-range strike capability into heavy defense zones. Many drones before in the war were shorter range. Ukraine's ability to reach Moscow region is game-changing. The FB-1 and similar systems bring ranges of over 1,000 km. Second, cost effectiveness. One article on FB-1 suggests unit cost around $55,000 as opposed to much higher cost of comparable missiles. That means Ukraine can deploy large numbers without breaking its budget, increasing the swarm volume. Third, stealth and evasion. The drones are designed to avoid detection, or at least to saturate defenses so some get through. Fourth, swarm tactics. Launching dozens or hundreds at once means the air defense becomes overwhelmed. Performance per unit is enhanced by numbers. Fifth, psychological and strategic impact. Striking deep inside the enemy territory, disrupting air traffic like airport closures, energy supply, and the symbolic heart of the enemy, Moscow, has a big impact beyond physical damage. Sixth, modular design. Warheads selectable for different missions, flexible payloads, possibly repairability or reuse of some subsystems. Seventh, adaptability and scalability. Ukraine's UAV production is ramping. Many previous barriers to long-range strike drones are being overcome. The unique combination of range plus cost efficiency plus stealth plus swarm density plus real operational impact make this set of drones stand out. It isn't just a drone, it's a strategic weapon system tier. That's the key selling point. Let's move on to price. In a commercial review, one would talk about MSRP. Here, we have to approximate what's publicly reported. For example, for the FB-1 drone, one source suggests an estimated cost of $55,000 per unit. Other sources may not publish costs, but the key takeaway is these are far cheaper than manned aircraft or large cruise missiles. The relatively modest cost enables production in larger volumes and makes losses more acceptable. From a budgeting perspective, Ukraine can afford to deploy dozens or even hundreds at one time. Also, if an individual drone is lost, the cost is small relative to the damage caused if it reaches target. So in effect, the price-performance ratio is excellent: low unit cost, high strategic reach. One caveat, we don't have full public disclosure of other drone models' costs, but based on the niche, it's safe to assume they are significantly cheaper than comparable long-range strike missiles. So in summary, purchase/production price, approx $0.000-100,000 range for some known models, making these accessible for large-scale deployment. Finally, the conclusion. To sum up, the use of Ukrainian drones turning Moscow into a firestorm represents a major shift in drone warfare and in strategic reach. The exterior spectacle, the drone swarms and fires deep in enemy territory, gets attention, but it is underpinned by a highly sophisticated interior engineering architecture that allows long-range, cost-effective, survivable strike capability. The performance is real. Deep penetration, high payload, effective disruption of critical infrastructure, airport closures, energy grid hits. The built-in safety features in military sense of secure navigation, counter, jamming, redundancy, self-destruct, and cost tolerance of losses make the system robust. The unique selling point, range, cost efficiency, swarm tactics, strategic impact make this capability stand out in modern warfare, with unit costs relatively low, tens of thousands of dollars compared to traditional weapons. The price aspect further enhances value. In the context of this conflict, the effect is not just tactical but strategic and symbolic. By reaching into the capital of its adversary, Ukraine sends a message. It can strike deep, it can innovate, and it forces the opponent to divert resources to defend the homeland. For viewers and analysts alike, this is a vivid demonstration of how unmanned systems are reshaping war. If you found this breakdown interesting, please subscribe and hit the like button. I'll be doing further deep dives into drone warfare and other tipping point capabilities in this war. Thanks for watching the WAR Diary, and I'll see you in the next video.